A runner in preparation for a race jogs at 6, 7, and 9 miles per hour and travels a total of 7.1 miles in 1 hour. The runner jogs 12 minutes longer at 6 miles per hour than at 9 miles per hour. How many minutes did the runner jog at each speed? So we start the problem by letting x equal the fraction of an hour that the runner jogged at 6 miles per hour. And so then what I'll do is let y equal the fraction of an hour that the runner jogged at 7 miles per hour. And then z will equal the fraction of an hour that the runner jogged at 9 miles per hour. Now we can set up a system of 3 equations with these 3 variables. The first equation we could set up is if x is the time and 6 is the speed, then 6 times x represents the distance that the runner jogged in this time. And similarly, we would have 7y and 9z, and each of those being a distance that would have to add up to the 7.1 miles that the runner jogged. Our second equation is the fact that the runner jogged for 1 hour. In other words, x plus y plus z, which are the 3 respective times, must add up to 1 hour. And then finally, we were told that the runner jogged 12 minutes longer at 6 miles per hour, which is the x. So x will equal 12 minutes longer than he or she did at 9 miles per hour. So that would be the z, plus the 12 minutes. Well, remember, 12 minutes needs to be converted to hours since x, y, and z are in hours, and 12 minutes works out to 0.2 or 2/10 of an hour. So now we have our system of 3 equations and 3 variables. The first thing I want to do is to substitute the value z plus 2/10 for each of the x's. So that would give us in this first equation 6 times z plus 2/10 plus 7y plus 9z equals 7.1. Simplifying this, we distribute the 6 to have 6z plus 1.2 plus 7y plus 9z equals 7.1. Now we can combine the z's together on the left-hand side, and we could subtract 1.2 from each side. This would give us an equation 7y plus 15z is equal to 5.9. I'm going to refer to this as equation number 1, and we'll come back to that. Next, I want to substitute the value of x equaling z plus 2/10 into this equation here. So therefore, we would have, writing it down below, z plus 2/10 plus y plus z equals 1. Combining z plus z and subtracting 2/10 from each side, I have the equation y plus 2z equals 8/10. I'm going to number that equation 2. And now what I need to do is combine these 2 equations in such a way to eliminate the y. To do that, what we would do is multiply this equation number 2 by -7 and then add it to the equation which I've numbered as 1. So I want to multiply this one by -7, and I'm going to put that result up above. So -7 times y is -7y. -7 times 2z is negative 14z. And negative 7 times 0.8 is negative 5.6. Remember, I want to add that to the first equation. 7y plus 15z is equal to 5.9. Adding the two equations, the y's are eliminated. I have positive z is equal to 0.3. Now that I have this value of z, I can substitute that into either of these two equations and find the value of y. But let me take the original equation number 2, the y plus 2 times z equals 0.8, and I'll substitute it in here. So I have y plus 2 times 0.3 equals 0.8. That means I have y plus 6/10 equals 8/10. Subtracting 6/10 from each side, I get y equals 2/10 or 0.2. Now I want to find the value of x. I can find the value of x by taking the original equation x equals z plus 0.2. And I can substitute the fact that z up here is equal to 3/10. So x is equal to 3/10 plus 2/10, or in other words, 5/10. Now, what we have is all of our answers in decimal form, which is a fraction of an hour. So we need to convert these. X equaling half an hour means 30 minutes at, remember, x was at 6 miles per hour. Y is equal to 2/10, and so that's 12 minutes. And remember, y was at 7 miles per hour. And finally, z is 3/10, which is 18 minutes, and that was at 9 miles per hour. So that's our final solution. 30 minutes at 6 miles per hour, 12 minutes at 7 miles per hour, and 18 minutes at 9 miles per hour.